This problem is following up directly on the heels of the work that we were doing in our last lesson. So first of all, if it helps you out, draw a picture of the situation. It always helps us kind of visualize what all is going on. In this case, we're getting a circular pattern that's being created when this thing is leaking out. And so, of course, that means we're dealing with a circle. And we have some radius of the circle. We know that that is increasing by 1 meter per second. And we know that right now that radius is 30 meters. And what we're wondering is how fast is the area increasing? Now the key word there is area, which tells us what equation we're going to be using, because we need to have an equation that's going to represent the area of the circle. So area of a circle in general is pi r squared. And since we're now trying to figure out the rate at which it's changing, we find our derivative with respect to t. So that's going to give us dA over dt equals pi times 2r times dr over dt. Remember, chain rule there by getting the dr over dt on the end. And then from there, we can go ahead and start plugging in. Now the dA over dt, that of course is what we're actually trying to figure out in this case, so we don't know it yet. But we do know what r is, so the r is 30, and the dr over dt is going to be 1. Now whenever you grab that number, take a moment, make sure that you are in fact plugging it in correctly when it comes to the sign. In this case, it is increasing at 1 meters per second. That's why I plugged in a positive. But I just changed that word to decreasing, and then all of a sudden it would be a -1. So do pay attention to that. All right, last step is to actually just do the calculations here. And when you do that, you end up getting 60 pi, or we can go ahead and calculate that out to a decimal. And when we get that answer, remember to include the units. And we can always know the units because whatever the units would be for the top of that, so that's the A. A is being measured in square meters here, over T on the bottom. And so the time, that's being measured in seconds. So that would be square meters per second there. And that one's done. All we got to do for it